Have you ever wondered if the universe could be a gigantic quantum computer? It's an audacious thought, isn't it? A notion that challenges the very fabric of our understanding. It's not just a flight of fancy, but a revolutionary idea that's been fueling scientific debate and curiosity. This idea proposes that our universe, in all its vast complexity, could be explained as an immense quantum computation. It's like imagining the cosmos as an intricate, unfathomably large machine, crunching numbers and spewing out the reality we know and experience. This concept, as mind-boggling as it sounds, isn't drawn from the pages of science fiction. It's an actual field of study, a convergence of quantum mechanics and computer science, pushing the boundaries of both disciplines and our perception of reality. It's a new lens through which we can view the universe, a perspective that could redefine our understanding of everything from the tiniest particles to the grandest cosmic structures. We're about to embark on an exciting journey into the depths of quantum speculation. Our guide on this journey is a man named Edward Fredkin, a pioneer in computer science and digital physics. Edward Fredkin's story is an intriguing one, beginning far from the hallowed halls of academia. He started his career as a fighter pilot, soaring through the skies. But even then, his curiosity was not confined to the physical world. His mind wandered to the mysteries of the universe, pondering the fundamental laws that govern our existence. Fredkin traded his pilot's wings for a professor's robe at the Massachusetts Institute of Technology, a transition as bold as it was unexpected. At MIT, he found the space to nurture his unconventional ideas that would eventually challenge the very foundations of physics. Fredkin proposed a radical theory, that the laws of physics are not abstract principles, but a cosmic computer algorithm. He suggested that our reality, in all its complexity, might just be a digital construct. This idea, which came to be known as digital physics, was a dramatic shift from the traditional understanding of the universe. But Fredkin didn't stop there. He ventured into the realm of reversible computation, a concept that was once considered impossible. Along with his collaborators Toffoli and Margolus, Fredkin introduced what are now known as the Fredkin and Toffoli gates. These gates, once seen as mere curiosities, laid the groundwork for a quantum revolution. Fredkin's theories, though controversial, have had a profound impact on our understanding of the universe. His work has paved the way for the development of quantum computers, machines capable of solving problems at speeds unimaginable to classical computers. Fredkin's unconventional ideas have paved the way for a quantum revolution. His journey from fighter pilot to MIT professor, from the skies to the mysteries of the universe, is a testament to the power of curiosity and the potential of unconventional thinking. As we delve deeper into the realm of quantum speculation, we can't help but acknowledge the indelible mark Edward Fredkin has left on our quest to decode the cosmos. In the world of computation, there were ideas once deemed impossible, such as reversible computation. Imagine a world where time could run backwards, where you could unspill a glass of water or unscramble an egg. This was the world Edward Fredkin dared to envision. Fredkin, along with his collaborators Tommaso Toffoli and Norman Margolus, introduced concepts that would become the foundation stones of the quantum revolution. They proposed the Fredkin and Toffoli gates, logic gates that are reversible. Unlike traditional logic gates, which erase information as they operate and thereby increase entropy, these gates preserve information. They represented a radical departure from the conventional approach, an approach that was, at the time, thought to be the only way. These gates, at first glance, might have seemed like nothing more than a curiosity, a theoretical exercise with no real-world application. But as it turns out, they were far more than that. These gates became the key to unlocking the potential of quantum computing. It was at the Physics of Computation Symposium in 1981 that Richard Feynman, a visionary in the field of physics, ignited the quantum spark. Feynman recognized the potential of these reversible gates. He saw that with them, a new kind of computer could be built, a computer that didn't just crunch numbers, but instead used the principles of quantum mechanics to perform calculations at speeds previously unimaginable. And so the quantum revolution began. Quantum computers capable of performing calculations at speeds that make classical computers look like abacuses owe their existence to the once impossible concepts of reversible computation. These once theoretical curiosities are now at the heart of a technology that has the potential to revolutionize everything from drug discovery to cryptography. But the story doesn't end there. With quantum computers now a reality, we're just beginning to scratch the surface of what's possible. Quantum computers, capable of unimaginable speeds, owe their existence to these once impossible concepts. What if the universe is a massive cellular automaton, a cosmic computer? This concept, the next progression of Edward Fredkin's digital physics theories, has ignited a revolution in our understanding of cosmology. Fredkin suggested our reality could be cosmic computer algorithm. However, the idea of a digital universe has criticisms. Some argue that classical computational models can't explain quantum phenomena, the strange behaviors seen in the subatomic realm. Nevertheless, could these quantum peculiarities be the key to the nature of our digital universe? Exploring quantum gravity theories, we see the merger of quantum mechanics and computational principles. Could the nature of space and time at the Planck scale reveal the quantum essence of reality? We examine this question, we're exploring testable hypotheses. Could the granularity of space-time at the Planck scale be the key to the universe's secrets? This exploration might affirm or challenge the concept of a digital universe. Throughout, we're reminded of Fredkin's unorthodox approach, potentially the catalyst for revolutionary discoveries. Our journey towards understanding the universe continues.